So these two slides actually just kind of reinforce something that's already been introduced in Chapter 3, and then again in introduced in Chapter 4, and then again in Chapter 5, we've been talking about the formation of clouds within a cloud and within something we call fog as 100% relative humidity is reached. So the same 100% relative humidity is what the atmosphere needs to reach in order for condensation to give us dew, or else direct deposition, what we call, to give us frost. So actually dew will form as the Earth cools off, as it re-radiates its thermal energy it got from the sun during the daytime, and as it cools off, if it cools off to the point of the air becoming saturated, reaching 100% relative humidity, we'll get a deposit of dew. Now, one of the things you might have noticed is that actually the presence of objects like trees and porches and that sort of thing kind of act to help keep the temperatures warmer than if those trees or porches weren't there. So in the vicinity of trees and porches and that sort of thing, it may not cool to the dew point temperature, and we may not get a deposit of frost or dew. In contrast to that, objects that cool quickly, such as cars, just because of the thermal property of all that metal, they will tend to, as they cool more quickly, they're more likely to reach that dew point or frost point temperature. They're more likely to go ahead, the air around them was more likely to become saturated. So if the dew point temperature is colder than the freezing point temperature of water, which in the Fahrenheit scale is 32, if the dew point temperature is colder than 32 degrees Fahrenheit, then when you reach saturation, that moisture is going to come out of the air. When you reach 100% relative humidity, you're going to be at the freezing point of water. So we use the word deposition to talk about water vapor skipping the liquid state and going directly from a vapor to a solid. That's what we call deposition. And remember that there is, in that situation, energy is released. There's a latent energy is going to be released during that phase change. So the dew point temperature is the temperature, or sometimes they just call it dew point. Dew point or dew point temperature, the same thing. The temperature the air needs to cool down in order for dew or frost to form. Yeah, I caught my own self here. So sometimes we differentiate if that temperature, as I said, was cooler than freezing, we would call it a frost point temperature instead of a dew point temperature. But I'd say on the internet they usually call it a dew point temperature, regardless.